Hi, my name is Carl Emanuel, and I'm a geologist that works for the Black Hills National Forest. One of the big things that I do every day is work with geologic maps and build geologic models. This is a model of the Black Hills and Bighorn uplifts along the South Dakota-Wyoming border, and it is an area where I'm studying the karst and cave resources. Now we're going to zoom in just a little bit closer on the Black Hills uplift on the right in just a moment. My karst inventory is using a variety of remote sensing techniques, and thousands of features have been identified so far, well over 10,000 at this point, and I expect to see at least 30,000 by the time this project is done. Karst features are really important to identify and protect because they are a direct pathway into the region's groundwater system. They provide every bit of the fresh water used in this area. Now we're going to zoom in a little bit and take a look at a detail of just one small area in the western part of the Black Hills. Every one of these little features that you see in front of you, the blue dots and the round circles and the magenta colors and the red lines, are showing where a cave or a karst feature is located. In the center part of the image right now, you see a magenta colored area that's kind of long and oblong and football shaped. Now, that area is one of the largest sinkholes that we found so far in this region. It's sitting out in the middle of the forest and appears to be nothing more than a meadow, but it is a major groundwater recharge area and needs to have protections put in place to make sure that we don't get any undue pollution into the groundwater system. There'll be an image, photographic image here, which shows what it looks like from the air. This feature is over 1,200 feet long by 600 feet wide with a deep sink in the center. It was never really recognized as a sinkhole in the past, and there are hundreds in the surrounding area and thousands across the Black Hills in general. As we zoom out, you will see other little black circles, which are smaller sinkholes which have been found in the adjacent area, and you will also see red, what appear to be like a red Y or a black Y, which show where known caves are. We're going to zoom in on one such cave, which has two very deep sinkholes right at the entrance and a little ways away from the entrance, and they're connected, and so the cave goes from one sinkhole to the next. This kind of information wasn't available in the past, and it is extremely useful in determining where and how we can protect these resources. Now we're going to go to an area where we've geologically mapped a large cave system underground. We do this so that we can manage the surface above to ensure that as little impact from surface activities happens as possible. This is the best part of my job and stuff I look forward to doing every day when I come in. Now, Adam will talk to you about another mapping project.
Hi, Carl was just talking to you about above ground geologic mapping when looking at karst features. We're going to look at mapping underground because it's done a lot differently than it is on the surface. So this cave on this map here I'm looking at on my computer is the same cave Carl was just showing you in his last slide. This cave is a really large cave and is very complex. And as we zoom in to the cave, you can see there's more and more detail on the cave map as you get closer. Some of the features you see in the map as you zoom in are different colors. These colors on this map indicate different levels of the cave, with yellow and colors closer to being yellow being closer to the surface, and darker reds and deep reds like this right here being the lowest levels of the cave. And this helps you navigate through the cave knowing which level you're traveling through as the map overlaps itself like it does right here where the passageways go underneath of one another. You'll also notice a number of lines in the map, like these green lines and red lines. And these we're going to talk about in a few minutes, but those are the survey laser shots. And we'll look at the laser here in just a minute. Most excitingly, on this map, because this cave is currently being actively explored by explorers, you see these openings in the map and these question marks. And what these indicate are places where no one's ever been before and we don't know what's there. So folks will go there in the future and find new cave and map it so that we know where the cave goes. And you might be asking yourself, why do we want to map caves and why is that important? And this is for a number of different reasons. And the two most important being that it's the only way that we know where the cave goes. So to protect the cave, we have to actually go there, and we have to measure the passageways and kind of discover where they're going, so that we can make sure no one puts pollutants in the cave or builds a rock quarry on top of the cave or damage it in many different ways. And it's also one of the last few places in the world where we can have true exploration, where people can go into places no one's ever seen before and find things. And you'll see on this map that there are some fun names like the Octopus or Thunderhall, and these places were all named by the explorers who found them. And that's kind of a fun thing to do when you're exploring caves. And there are lots of different cave maps that you can do, and we'll look at some over here. So there are maps that are very simple, like Ice Cave, which is located here in the county that I live in. And as you can see, Ice Cave, it's essentially one really big room. And so you walk in at the entrance up here, and it's a giant room. And then sometimes a year there's an ice column in there. So when we're mapping the cave, we do often two different views of the cave on the map. We do a plan view, which is from the top down, and we do profile view, which is looking at the cave from the side. And you can see in the profile view, we went ahead and put in the ice column, so folks will know where to expect that when they go visit the cave during those times of the year, and they'll know if it's there or not pretty quickly. And so there's simple caves like Ice Cave, and there's really complex caves like this map here, which is just a very small portion of the third longest cave in the world, which is also located near my home. So this cave has hundreds of miles of passageway, and it's taken decades to map. And so you can have really small projects, which will take a couple hours, like Ice Cave, or you can have really long, big projects like this cave, which have taken 3 generations at this point to make this map. And it's a really pretty neat thing that at the end of the day, you can have something that, you know, people will be doing just like you were, going through the same passageways that you found generations from now. And so you might be thinking, how do you make the maps? Like, what are you using? So these are the tools, some of the tools that we use to make the maps. Currently, the tool that we use is this. This is called a Disto X2. And there are not very many of these in the world, but all of them are used for cave mapping. And just like Carl mentioned to you, his data came from LiDAR. And LiDAR is essentially lasers coming from airplanes to map the valleys and hills on the ground. Our lasers map the inside of the cave. And so basically the laser can take 3 different measurements with each shot. It can give you the distance, and it can give you the azimuth, which is the direction, and it gives you the inclination, which is the up and down. Okay? And we use those shots to make the lines that we saw in the map before, or in our survey sketch paper, which we'll look at in just a moment. And so using those, we can measure the cave very accurately. And so this is today's model. The old days, people used things like this, which this is called a Cento Tandem, and before this there was a Brunton. And so these are handheld instruments that people still use today to look through to take those same measurements with some kind of measuring device for length, like a tape measure, to get the same readings we take today. In the future, will most likely be this for a while, and this is called a Brick 4. And it's in this case because oftentimes we're in wet environments, or it's very harsh conditions and rocky or cold. In this case, protects the unit. So you turn it on, and it has a computer here. And this computer, just like the Disto X, has a laser, and that laser takes very similar readings, except in a new device, which is still being produced today, and the Disto X is not, sadly. So this is what we're going to work with from now on. And so once you have all these readings, to get to your map, you have a person who's called a sketcher. And the sketcher takes those readings, and you can see the lines, like we saw in the previous thing on this sketch, which are hand-drawn on here very accurately with a protractor, and then they map out the cave passage around it. And you can see there's many different symbols on this sketch. There's water, there's mud, there are obviously big rocks, and these little triangle things are stalactites. And so the cave map and the symbol show us many different things, which eventually will get us from this sketch to a map like the ones we've looked at already today. So if you think drawing is fun, or crawling around, or climbing sometimes, or going on trips with your friends, maybe cave mapping would be something that would be fun for you to do, and something that you can certainly get into more. And to learn more about cave mapping and caves in general, please visit the NSS at www.caves.org. And thank you, Carl, who's with us today from the U.S. Forest Service, for helping us learn about surface mapping in geologic areas of karst. So thank you for visiting us during Earth Science Week.